Chemistry, 10th unit, man-made materials. 10th unit is man-made materials. Soap. What is a soap? Soaps are made up of sodium or potassium salts of higher fatty acids like stearic acid, oleic acid, palmitic acid, etc. Soaps are made up of sodium or potassium salts of higher fatty acids like stearic acid, oleic acid, palmitic acid, etc. Soaps are obtained by the alkaline hydrolysis of oils and fats. Soaps are obtained by the alkaline hydrolysis of oils and fats. Glycerides of fatty acids give soaps on alkaline hydrolysis. Glycerides of fatty acids give soaps on alkaline hydrolysis. Raw material required for manufacturing soap. Raw materials required for manufacturing soap is first one, oil or fat, that is mustard oil, mahua oil, coconut oil, cottonseed oil, olive oil or animal fat. First one, oil or fat, that is mustard oil, mahua oil, coconut oil, cottonseed oil, olive oil or animal fat. Second one, fillers, the substance added to increase the weight and volume of soaps. Example, sodium silicates, sodium stone, starch, sodium carbonate. Second one, fillers, the substance added to increase the weight and volume of soaps. Example, sodium silicate, sodium soapstone, starch, sodium carbonate. Third one, alkali, caustic soda for hard or washing soaps and caustic potash for soft soaps is used for saponification. Caustic soda for hard or washing soaps and caustic potash for soft soaps is used for saponification. Fourth one, coloring materials, that is ZNO is for white color, methylene blue is blue color, uranium is yellow color, leucine is red color. Coloring material, ZNO is for white color, methylene blue is for blue color, uranium is for yellow color, eosine is red color. Fifth one, perfumes. Perfumes are used to make soap pleasant smelling. Example, lemongrass oil. Perfumes are used to make soap pleasant smelling. Example, lemongrass oil. Cleansing action of soap. Cleansing action of soap. A soap molecule is made up of two parts. A long hydrocarbon part, that is hydrophobic, and a short ionic part containing COO minus Na plus group, that is hydrophilic. A soap molecule is made up of two parts. A long hydrocarbon part, that is hydrophobic, and a short ionic part containing COO minus Na plus group, that is hydrophilic. When soap is added to dirty clothes soaked in water, the greasy and oily dirt particles attach themselves to the hydrocarbon part of the soap molecule. When soap is added to dirty clothes soaked in water, the greasy and oily dirt particles attach themselves to the hydrocarbon part of the soap molecules. The ionic part of the soap molecules remain attached to water. The ionic part of the soap molecule remain attached to water. When the dirty cloth is agitated in soap solution, the dirt particles attached to the soap molecules get washed away in water and the cloth gets cleaned. When the dirty cloth is agitated in soap solution, the dirty particles attached to the soap molecules get washed away in water and the cloth gets cleaned. Synthetic detergents. What are synthetic detergents? These are also called soapless soaps as they do contain the usual soap like sodium stearate, etc. Synthetic detergents are also called soapless soaps as they do contain the usual soap like sodium stearate, etc. These are sodium salts of a long chain benzene sulfonic acid or the sodium salt of a long alkali hydrogen sulfate. These are the sodium salts of a long chain benzene sulfonic acid or the sodium salt of a long alkali hydrogen sulfate. Synthetic detergents can be used even in acidic solutions and have a strongest cleansing action. Synthetic detergents can be used even in acidic solutions and have a strongest cleansing action. These are more soluble in water and can be used with hard water as these produce no precipitates with Ca2+, Mg2+, Fe3+ ions present in hard water. Synthetic detergents are more soluble in water and can be used with hard water as these produce no precipitates with Ca2+, Mg2+, Fe3+ ions present in hard water. Biological degradation is an important property of a good detergent. Biological degradation is an important property of a good detergent. Glass. Glass is an inert, amorphous, hard, brittle, supercooled liquid. It is not a true solid. Glass is a inert, amorphous, hard, brittle, supercooled liquid. It is not a true solid. Chemically, glass is a mixture of number of silicates and has no definite formula. Chemically, glass is a mixture of number of silicates and has no definite formula. But the average composition can be represented as X M2O Y M-O 6SiO2, where M is monovalent alkali metal like Na, K, etc. M- is a bivalent metal like Ca, Zn, Pb, etc. and X, Y are whole numbers. Chemically, glass is a mixture of number of silicates and has no definite formula, but the average composition can be represented as X M2O Y M-O 6SiO2, where M is monovalent alkali metal like Na, K, etc. M- is a bivalent metal like Ca, Zn, Pb, etc. and XY are whole numbers. Types of glasses. Types of glasses is as shown in the diagram of in the video. This is type of a glass. It is common glass or soft glass. Its chemical formula is Na2O CaO 6SiO2. Its properties is soft, low melting point, and its uses is best bottles, test tubes, pass window, etc. Second one is hard glass or potash lime glass. Its chemical formula is K2O CaO 6SiO2. Its properties is hard, high melting point, and its uses is flasks, hard glass apparatus, etc. Third one is flint glass or lead potash glass. Its chemical formula is K2O PbO 6SiO2. Its properties is soft, transparent, high refractive index, and its uses is making prism, lenses and electrical instruments. Fourth one is Pyrex glass or borosilicate glass. Its chemical formula is Na2O B2O3 Al2O3 SiO2. Its properties is low coefficient of expansion, heat resistant, and its uses is good quality glass weights. Fifth one is Crookes glass. Its chemical formula is K2O PbO Ce2O SiO2. Its properties is soft, transparent, cuts off UV rays. Uses is eye lenses. Sixth one is safety glass. Its chemical formula is a layer of transparent plastic between two layers of glass. Its properties is it doesn't break into pieces. Uses is windscreen of automobiles, aeroplanes, trains, etc. Seventh one is reinforced glass. Its chemical formula is it has a network of whites. Properties is fiber like structure, and its uses is thermal and electrical insulators. Raw materials. What are the raw materials? The important raw materials used for the manufacturing the glass are metal salts. Example, Na2CO3, NaNO3, CaCO3, BaCO3, etc. The important raw materials used for the manufacturing of glass are metal salts. Example, Na2CO3, NaNO3, CaCO3, BaCO3, etc. Oxides of transition metals are used to obtain colored glass. Oxides of transition metals are used to obtain colored glass. Okay, coloring materials and its color. SeAuCu2O is dark red, COO is dark blue, MnO2 is violet color, Cr2O3, FeSO4 and Cu are green color, CD, SB, Fe, U are in yellow color, Na3AlF6 is milky white, NiO is black. Coloring material and its color is SeAuCu2O is dark red, COO is dark blue, MnO2 is violet, Cr2O3, FeSO4, Cu are in green color, CD, SB, Fe, U are in yellow color, Na3AlF6 is milky white, NiO is black. The process of cooling of glass is called annealing of glass. The process of slow cooling of glass is called annealing of glass. Properties of glass. Properties of glass. Glass is a mixture and not a compound. Glass is a mixture and not a compound. Glass stoppers should not be used in containers of NaOH or KOH. Glass stoppers should not be used in containers of NaOH or KOH. Glass is soluble in HF due to formation of H2SiF6. Therefore, HF solution is used for etching glass. Glass is soluble in HF due to formation of H2SiF6. Therefore, HF solution is used for etching glass. Cement. It is a dirty greyish heavy powder containing limestone and clay. Cement is a dirty greyish heavy powder containing limestone and clay. When mixed with water, it becomes hard stone-like mass similar to Portland rock, a famous building stone of England. When cement is mixed with water, it becomes hard stone-like mass similar to Portland rock, a famous building stone of England. So, it is also known as Portland cement. Cement is also known as Portland cement. It was first named by Joseph Aspdin. Cement is first named by Joseph Aspdin. Portland cement and was discovered in England. Portland cement was discovered in England. The approximate composition of Portland cement is as follows. The approximate composition of Portland cement is as follows. Calcium oxide is 62%, silica is 22%, alumina is 7.5%, magnesia is 2.5%, ferric oxide is 2.5%. Calcium oxide is 62%, silica is 22%, alumina is 7.5%, magnesia is 2.5%, ferric oxide is 2.5%. Its raw material. Raw material of cement is limestone and clay. Limestone provides CaO while clay provides SiO2, Al2O3 and Fe2O3. Raw materials of cement is limestone and clay. Limestone provides CaO while clay provides SiO2, Al2O3 and Fe2O3. Excess of silica, that is SiO2, decreases the setting time of cement, and alumina increases the setting time of cement. Excess of silicon decreases the setting time of cement and alumina increases the setting time of cement. Hydration of cement is an exothermic process. Hydration of cement is an exothermic process. In clinker, 2 to 3 percentage of gypsum, that is CaSO4 to H2O, is added to slow down the setting of cement so that it becomes sufficiently hard. In clinker, 2 to 3 percentage of gypsum, that is CaSO4 to H2O, is added to slow down the setting of cement so that it becomes sufficiently hard. Important processes with their compounds. Bosch process, hydrogen. Nelson cell, NaOH. MacArthur Forest process, Ag, that is cyanide process. Mond process, Ni. Habert's process, NH3. Bickland ID process, NO-HNO3. Ostwald process, NO-HNO3. Deacon's process, Cl2. Lead chamber process, H2SO4. Contact process, H2SO4. Important processes with their compounds. Bosch process, hydrogen. Nelson cell, NaOH. MacArthur Forest process, Ag, cyanide process. Mond process, Ni. Habert's process, NH3. Bickerland ID process, NO-HNO3. Ostwald process, NO-HNO3. Deacon's process, Cl2. Lead chamber process, H2SO4. Contact process, H2SO4. Some important compounds and minerals. Magnesite, Mgco3. Epsomite, MgSO4 7H2O. Sorrel cement, MgCl2 5MgO XH2O. Limestone, marble, chalk, that is CaCO3. Gypsum, CaSO4 2H2O. Plaster of Paris, CaSO4 half H2O. Quicklime, CaO. Slaked lime, CaOH2. Cornellite, KCl MgCl2 6H2O. Permutit, that is geolite, is Na2Al2SiO4 XH2O. Soda ash, unhydrated NaCO3. Washing soda, Na2CO3 10H2O. Crystalline carbonate, Na2CO3 H2O. Marshall's acid, H2SO8. Borazine, inorganic benzene, is B3N3H6. Blue vitriol, that is CuSO4 5H2O. Horn silver is AgCl. Philosopher's Wood, ZnO. Corundum, Al2O3. Bauxite, Al2O3 2H2O. Green vitriol, FeSO4 7H2O. Carborundum, that is SiC. Calomel is Hg2Cl2. Freon, CF2Cl2. Laughing gas, N2O. Oil of vitriol, concentrated H2SO4. Oleum is H2S2O7. Producer gas is CO plus N2 plus H2. Refrigerant is NH3, CF2Cl2, CO2, etc. Fertilizers. What are fertilizers? The chemical substances which are added to the soil to increase its fertility and make up for the essential nutrients which are lost due to continuous cropping are called chemical fertilizers. These are added to the soil during sowing season to avoid starvation of the plants. What are fertilizers? The chemical substances which are added to the soil to increase its fertility and make up for the essential nutrients which are lost due to continuous cropping are called chemical fertilizers. These are added to the soil during sowing season to avoid starvation of the plants. This is the chemistry 10th unit, that is man-made materials. Okay, thank you so much.